When you think about most big ideas, you probably picture them starting in some quiet lab or a university lecture hall. But the story of software engineering? Wow, that's a different beast entirely. It's the discipline that builds our entire digital world, and its origin story is, well, it's pretty wild. It wasn't born from quiet contemplation, no. It was forged in a global crisis that almost brought the brand new age of computing to its knees. Okay, let's dive into this incredible story. It sounds like the setup to a really strange joke, doesn't it? I mean, what on earth could the iconic 1969 music festival, the ultimate symbol of freedom and counterculture, possibly have to do with this sleek, hyper-organized little device sitting in your pocket? Well, the answer is pretty much everything. They are two sides of the exact same chaotic revolutionary coin of the late 1960s. So picture this. While the whole world was watching this massive cultural revolution unfold, Woodstock, protests, a total rejection of old structures, a hidden, silent crisis was brewing in the world of computing. While one world was embracing chaos, the tech world was being absolutely consumed by it. And this period of chaos wasn't just a rough patch. It was so severe, so completely out of control, that it earned this epic name that's gone down in tech history, the software crisis. This was the exact moment when the freewheeling, artistic, let's just code approach simply shattered. And look, this wasn't just some nerdy niche problem that only programmers were worried about. Just listen to these words from one of the absolute giants of computer science, Edsger Dijkstra. Back in '72, he just laid it all out there. He's basically saying, hey, the world is losing its patience with us. Society was starting to depend on software, but the people building it just couldn't deliver anything reliable. The stakes were getting incredibly high. So what did this crisis actually look like on the ground? Well, it was a mess. You had projects that weren't just a little late. We're talking years behind schedule. They weren't just a bit over budget. Costs were completely out of control. And the software that finally got delivered, often riddled with critical bugs, making it unreliable and an absolute nightmare to maintain. The age of the lone genius programmer hammering out brilliant code was over. The complexity was just too much. So, how did we even get here? What caused all this chaos? Well, first, demand just exploded. Suddenly, everyone wanted software for everything. And second, and this is the real kicker, the complexity of that software grew exponentially, way faster than our ability to actually manage it. It's like we were trying to build skyscrapers using the techniques for building a garden shed. It was a craft, a kind of art. But what the world desperately needed was a disciplined, predictable engineering practice. Okay, so things were breaking down. The industry had to do something, right? And the solution, it didn't come from a single company or some lone inventor. It came from a series of landmark gatherings where the brightest minds in the world came together to figure out a new path forward. And this is the turning point. It's kind of wild. In 1968 and 1969, and get this, they were funded by NATO. Yeah, that NATO. Two conferences were held. These weren't just boring academic talks. They were emergency summits. You had over 50 experts getting together to officially name the problem, the software crisis, and, way more importantly, to start inventing the solution. And this is what they came up with. Right there at that 1968 conference, the term software engineering was officially born. Just listen to those words again. Systematic, disciplined, quantifiable. I mean, that is the polar opposite of the chaos they were living in. It was a declaration, a statement, that building software shouldn't be like folk art. It should be like building a bridge, with rigor, with standards, and with a predictable process. All right, so they had a name for it. Software engineering. Awesome. But, naming something is the easy part. Building it, that's a whole other story. The next decade was all about creating the real tools and models that would turn this big idea into a reality. So let's meet the pioneers who drew the first blueprints. Our first pioneer is a guy named Winston W. Royce. He was working in the aerospace industry, so he had seen firsthand what happens when super complex projects don't have a solid structure. So in this hugely influential paper in 1970, he laid out a clear step-by-step process for building large software systems. He described what we now call the waterfall model. And the logic is actually super simple, but it was revolutionary at the time. You fully complete each stage before you even think about moving to the next. You figure out all the requirements, then you design the entire system, then you build it, and so on. It's linear, it's structured, and it was the very first real attempt to bring engineering-style order to the chaos of software development.
But as you can probably guess, one size never fits all, right? Another pioneer, Barry Boehm, he looked at waterfall and thought, for these massive, high-risk projects, that's like building a bridge from one side to the other with absolutely no way to turn back if you mess up. So he came up with something called the spiral model. Instead of a straight line, think of it, well, like a spiral. You build a little, test it, get feedback, and spiral back to make it better. This introduced that critical idea of feedback and refinement, planting the seeds for what would eventually become modern agile.
And it wasn't just about diagrams and processes. You can't forget the people. Frederick Brooks, who managed the gigantic OS 360 project for IBM, wrote this book, The Mythical Man-Month, and it basically became the Bible for anyone trying to manage a software project. He showed that you also had to solve the deep challenges of communication and teamwork. Okay, so the big ideas are starting to take shape. The theories are there. What's the next logical step? Making it official. It was time to build the institutions and the educational programs that would turn software engineering from a set of good ideas into a true, lasting profession. And man, once the ball got rolling, it moved fast, incredibly fast. In 1984, the US government funds the Software Engineering Institute. Just 3 years after that, the first ever university degree in the subject pops up in London, and by 1998, you could get a PhD in it. Think about that. In just a couple of decades, this went from a desperate idea thrown around in a conference room to something you could dedicate your entire academic career to. That's insane. And that Software Engineering Institute, they gave us something really crucial called the CMMI. It's a framework that gave organizations a real way to measure how good their development processes were. It was basically a standardized report card for how well you build software, letting you move from chaotic all the way up to optimized. And the demand for this new profession, it just exploded. By 2004, just a few short years after those first degree programs started, we're talking about roughly 50 universities in the United States alone offering dedicated software engineering degrees. The profession wasn't just here to stay, it was taking over. So, okay, that's a cool history lesson, but why does any of this matter to you right now? Because literally everything in our digital world today, from the apps on your phone to the cloud, it all stands on the shoulders of the solutions born out of that crisis back in the 60s. Seriously, you can draw a straight line from those early pioneers to all the buzzwords we use today. Agile? Yep, that's the evolution of the spiral model's iterative ideas. DevOps and CI/CD? That's the grandchild of CMMI's intense focus on process and quality. They are all children of that original crisis. And that brings us full circle, right back to our crazy question at the beginning. What does Woodstock have to do with your smartphone? Here it is. The stable, reliable apps on your phone work because of the chaos of the 1960s. That chaos forced a generation of brilliant people to stop treating software like a hobby and start treating it like the serious engineering discipline it had to become. Which, of course, leaves us with one last massive question for the future. We solved the first software crisis. We built the tools to handle that wave of complexity. But today, we're staring down the barrel of entirely new kinds of complexity with things like AI and quantum computing. Are the principles that got us here going to be enough for what's next? What new discipline, what new kind of engineering will the next crisis demand? Now that's something to think about.